So hello guys, what's up? We are back again with another question from our DSA challenge series. So let's get started. So guys, today our question is design a circular queue. Now, what do you mean by a queue and a circular queue? So a circular queue, first of all, a queue is a data structure in which we push from one end and pop from the other end. That is, we push in the rear end and pop from the front end. And circular queue means that we are utilizing the space optimistically. So for example, okay, so let's see in the whiteboard. So for example, if we have inserted 2 here, now I popped 1 here. So I inserted 1, 2 and 3. Okay, so now I popped here. So if in a normal queue, what it will show that the queue is empty, but there is still a space and which can be utilized in the circular queue. So we need to design that only. So let's see how we can do that. Okay, so we need to design enqueue function. That is, we need to how we can insert it, dequeue how we can delete, front we need to get the front element, rear element, empty condition, full condition. Okay, so let's see and see this through example so that we understand better. So what can be the initial condition? We can take two pointers, rear and front, and initially they will point to -1. They will point to indexes of front and rear, and we will use array as our queue. Also, we will have a size which will be initialized to k, which is given in the question. So rear and front will be initialized to -1, which will in afterwards become our empty condition. So our empty condition is what? Rear and front will be at -1. They are not initialized. So if whenever rear and front are at -1, we can assume that our queue is empty. Now let us understand it using a example. Okay. So what this example says. Okay, so first they have initialized my circular queue with 3. Okay, so we have initialized 3. So we will take an array of size 3. So first operation is NQ. So first front and rear are -1. So they both will point to 0 as I NQ the first element. So 1 will be inserted here. Then 2. So insertion is always done at rear. So rear will move here and 2 will be inserted here. Then 3. So 3 will be inserted here and rear will point here. Now again NQ function will be called. Now is full, we have to check the condition if it is full. So the queue is actually full. So we can't return, so we will return a false. Okay, we will see in the code as well. So we will return false here. So this is also done. Now rear, so rear we will simply return ARR of rear if it is present, else we will return -1 if the rear is pointing to -1. Now what will be the is full condition? Okay, so is full condition will occur when there is no space even after moving circularly. So we can say that the condition will become rear plus 1 percentage of size, rear plus 1 percentage of size should yield me what? Should yield me what? Should yield me front. So if that is the condition, we will consider the queue as full. So is full is also done. So DQ. Now what is DQ? DQ we have to pop from front. So we will simply remove it and front will move to the next pointer. NQ. Now we can NQ. So we will move the rear. So rear plus 1 percentage size. So rear will become 0. So rear will move here and we will simply NQ 4 here. Okay. And we can return rear as 4. So yeah, guys, in this way we can do that. Let's quickly go through the code as well. We have done almost similar things. So we have 4 things: array, rear, front pointers, and a size variable. We have initialized all of them in the constructor. Now let's see the enqueue function. In enqueue function, what we are doing? We are checking if it is full. If it is full, then we will return false. So let us see the full. Code full is simple. If real plus 1 percentage size is equals to front, then we will return true. That is, it is full. If it is not, then it is false. So if it is not full, then we can NQ. Now we have to check if there are no other elements. So if there are no other elements, then we will bring front and rear to 0 and simply insert the value at rear and return true. Else, the normal case, we will simply increment the rear and ARR of rear is equals to value. Now, what about DQ? So if is empty, then we will return false. So if the queue is empty, then we will return false. If front equals to rear. Now, this is the case where only one element exists. That is, if front is equals to rear, so one element. So we have to make those -1. Okay. Now, what we can do, we can simply front is equals to, if it is a normal case, then front is equals to front plus 1. In front, we will return ARR front. If it is not existing, we will return -1. Okay, so is full condition, is empty condition, we have seen it all. So yeah, guys, this was all from this question. Thank you so much, guys, for watching this video. Just in case you like the video, you like the question, make sure you hit the like button, press the subscribe button, share it with your friends. We shall see you next time.